Hi, everyone. Thanks for joining us today. My name is Bonnie, and I lead product marketing at Vespa, and I'm joined today by Zohar, who is our lead solution architect. Now, today we'll be talking about how to solve the relevance problem in e-commerce, which is part of our webinar series on AI challenges in e-commerce. But before we get started, a few housekeeping notes. This session is being recorded, and you will get a copy of the recording and the slides within 48 hours after the webinar ends. We'd love to get your thoughts and questions. So you'll see a few options on your screen in the right-hand toolbar. You'll see a Q&A option there. You can drop your questions here and we'll address these at the end of the session. And you'll also see a resources tab where we dropped in some helpful assets for you. So that also includes the link to registering for the AI and e-commerce series. Now with that, let's go ahead and get started. Today, we'll walk through what the relevance problem really is, why traditional architectures struggle to solve it, and how Vespa approaches relevance differently. Then we'll wrap with a demo and finally key takeaways before opening things up for your questions. So let's talk about relevance. Now, when most people think about relevance, they usually focus only on the user experience. But in reality, modern relevance impacts three major areas of the business. So, first, as you can expect, is customer experience. Users expect results that reflect their intent, not just their keywords. So, even if they misspell something or describe products in their own words, they expect to have accurate and personalized results. The second area is business control. So merchandising teams often need to influence results. So whether it's for promoting certain products or optimizing for margin or reacting to inventory and seasonality, they'll want to have some form of control over those results. And the third piece of this is infrastructure. So, all of this logic, the search, ranking, personalization, and machine learning, all of that needs to be able to run efficiently and effectively at scale. Now, the challenge is that most systems were never designed to handle all of those three dimensions together. Now, to make this idea of the big three a little more concrete, let's walk through a simple example that I recently heard. So, as many of you know, during the Winter Olympics, Team USA and Team Canada, they played a major hockey game with millions of fans watching, and it was a very exciting game. Now, imagine you're running an e-commerce site selling athletic apparel and footwear. Right after the game ends, people jump online to buy merchandise connected to the moment. So if a shopper comes to your site and they search for Nike shoes, at first glance, that may sound like a pretty straightforward search. But when you think about it, I mean, the system has to make a fairly complex decision about what results to show first. So, starting with the customer experience, which is that first pillar there, from that shopper's perspective, the best results are the ones that feel most relevant to what's happening right now. So, if Team USA won the game, fans might be wanting products that help them celebrate that moment. So, maybe they're looking for Nike shoes with Americana inspired designs, for example. And if Canada won the game, you'd want to do the same thing there. Um, or, even products tied to the Olympic campaign in general. So, if those products appear at the top of the results, the experience feels more timely and intuitive. So they'll feel more like the site, understands what they're looking for in that moment. So that really reflects that user intent. Now, on the business side of that, you want to think about how retailers often want some level of control over ranking so that they can align product discovery with marketing campaigns or merchandising strategies. So in this case, the merchandising team they may want to actively promote products connected to the Olympics event. So could be the Nike shoes that are part of a special campaign or products that are tied specifically to the Team USA theme. And they might even want to prioritize items that have a strong inventory or higher margins. So here, the ranking system isn't just optimizing for relevance; it's balancing customer intent with business priorities. Then you take a look at the third piece, and that's the infrastructure. The system has to incorporate all of these signals, things like query relevance, product attributes, campaign boosts, and even real-time events like the outcome of a hockey game, and evaluate them together in milliseconds. And it has to do that across a catalog that might contain millions of products, while thousands or even millions of shoppers are searching at the same time. So what looks like a simple search query like Nike shoes is actually a balancing act between those three different dimensions. So that's really what we mean when we talk about relevance being shaped by these three forces. Relevance isn't just a search. So, digging into another important point, and that is relevance is not a single metric. It's actually multidimensional. So, when a user searches for something like running shoes, there's not just one correct answer. So, again, we're looking at all those different signals, like what's textually relevant, the item that's currently in stock, or what's more likely to convert for that specific user. Each of these represents a different signal. But when you take ranking into consideration, which one should appear first in ranking? Now, the answer is that it depends because the most relevant item might not be in stock. The most profitable item might not match the shopper's preferences. And the most personalized item might not be part of the current campaign. So that's what modern relevance actually is. It's a decision problem where many signals need to be evaluated together. And that's where traditional architectures start to struggle because they're not designed to combine all of these signals efficiently. So let's take a look at how traditional systems handle relevance. Now, most companies try to solve this problem by stitching together multiple systems. You typically see that they started with a search engine for keyword retrieval and then added on a vector database for semantic search. And then you get separate ranking pipelines and other systems for personalization. Now, at first, it may seem flexible, but in practice, it actually introduces several major problems. One of these is signal fragmentation. Each system processes signals independently, which makes it difficult to evaluate all of them together. Then you get into the external ranking pipelines. Now, machine learning models often run outside the search engine, and this can create a slower feedback loop between the retrieval and ranking, which then leads to the operational complexity. So even small ranking changes can require re-indexing data or updating multiple pipelines. And then finally, you get limited optimization. So when signals are split across systems, it becomes very difficult to optimize for multiple objectives simultaneously. And this is actually the problem that Vespa was designed to solve. So I'm going to hand it over to Zohar to talk more about how Vespa solves the relevance problem. Zohar?
Okay, thank you, Bonnie. So let's explore further a little bit what the Vespa platform is. Vespa is a unified platform combining retrieval, ranking, and serving in real time. So let's explore a little bit what this enables. First of all, it enables unified retrieval. And unified retrieval means semantic search, lexical search, and structured filtering happening in a single hybrid query. In practice, think of a shopper who uploads a photo of a jacket that they like, a picture of a jacket, and then they can add a query text to express their intent and sets a price range. In Vespa, this translates into a single hybrid query combining lexical search, semantic search, and the semantic search will be both on the image and the query terms, along with structured range filtering on the price. All of this will be computed in a single pass after optimizing the query. Intelligent ranking and inference is where Vespa truly differentiates. Vespa goes beyond standard semantic ranking signals like BM25, term proximity, the kind of lexical signal you found in legacy Lucene based platform. or similarity calculation like cosine distance found in typical vector database. With Vespa, you can write your own ranking expression combining both lexical and similarity signals. You can do your own math around complex machine learning models directly during query time and factor in real-time signals like inventory levels, user click-through history, margin targets. All of this is computed locally on the node where the data lives, and retrieval happens without any round trips to any external system. Finally, Vespa is a production grade scale platform. This means that Vespa can handle billions of documents, products, and thousands of query per seconds, all within milliseconds. This is an infrastructure that major e-commerce sites rely on for the core search and recommendation experiences. Next slide. Now the tensors. Let's discuss a little bit the tensors. Tensors give you control over how relevance is actually computed. So a tensor can be as simple as a scalar, so a float value, just a number like a weight of a query term. A tensor can be sparse. A sparse tensor is a key value pair, which could, for example, represent user preferences for a fashion item, like the color, the style, the design of a t-shirt. And it can also be a dense multi-vector structure, like a Colbert type embedding for embedding like ColPaly for vision language models. This flexibility means that tensor can represent complex data modalities. This could range from product attributes, like the example I was just giving you. They could be user preferences, they could be business rules, all within the same unified framework. Not only you can represent complex data modality for ranking purposes, but Vespa lets you perform calculations on these tensors using ranking expression. For example, you can compute a dot product between a sparse user preference tensor and product attribute tensors to deliver personalized search experience using, a very intuitive tensor math. You can also layer additional tensor math to apply business rules, like ranking higher items that are high in stock or boosting active promotions. And you can run machine learning models directly as part of the ranking expression, such as a propensity to buy model to score candidates leveraging real-time signals at query time. Let's double click on Vespa's unique multi-phase ranking. Multi-phase ranking is how Vespa delivers machine learning powered accuracy without sacrificing performance. And all of this happens in real time at query time for every single request. Multi-phase ranking is an approach where we can filter and rank progressively using increasingly expensive ranking on a shrinking number of candidates as we go through each phase. So, for example, for phase one, lightweight ranking, uh, this phase would happen during match phase and use a fast, low cost operation across the full candidate pool. For example, let's say you have billions of products. So for semantic search, you would be doing a Hamming distance on bit quantized vector combined with a BM25 lexical search, which is compute at scale, and that will quickly narrow down an initial list of candidates. The phase two in this example would re-rank that initial list of candidates and, for example, apply full float precision similarity score on a reduced set in order to get a more precise cosine calculation and combine it with business rules. For example, it could re-rank based on inventory level, active promotions, margin targets, and any other real-time signal that we want to take into consideration. And this will identify the best candidate on each content node. Finally, the global ranking would merge candidates across all nodes, and you can now apply a more expensive machine learning model on a lesser set of candidates, like a propensity to buy predictor, to select the best result for the entire data set. The outcome, we are now able to surface the best product for both the customer and the business, and we can do all of that at millisecond latency. Handing it over back to you, Bonnie.
Okay, now we will go ahead and share a demo with you to give you an example of what this can look like in practice. In this demo, I'll share how you can combine Vespa's ranking capabilities into human controllable parameters where your teams, especially non-technical teams, can control ranking outcomes. Vespa ranking capabilities can enable you to implement any type of ranking profile, re-ranking, or business logic. Let's start by seeing how we represent different functions, which are basically configured as ranking profile expressions and can be controlled through a simple UI approach. As you can see here, we have different functions defined from standard text controls. So semantic weights and title weights will be passed to a ranking profile to weight these two in particular to describe how important this text ranking is to our final ranking profiles. We can also control any other function. Those pre-configured are just in the examples, like discount levels. So how important will discount level be to the whole ranking procedure? Popularity, user rating, gross profits, stock levels, conversion rates, personalization, or let's say, for example, transport. Those will be parameters which can be passed with the queries to control those elements. Now, the query will also require some context. For example, when we go to the category pages, we need to say what kind of category that is. In the configurations, we are able to set how this will be used. Is it going to be used for filtering or just for ranking selection? So if we go to a category page, for example, shoes, we need to use this parameter for filtering as well as the ranking selection. If we don't say ranking selection, that means that parameter will not be passed to the ranking selection, and then global ranking will be applied. We can configure as many parameters as we want. For example, collection, colors, vendors, and anything else here. Now we also have the other elements of our ranking, which are called assignment groups. Assignment groups are used to basically separate traffic for different purposes. For example, we can have development traffic, production, test group A, B, and many more. It's fully configurable, so you can create as many groups as you want for traffic selection. The last parameter for the configurations is to actually understand and see how our organization can be put together. If we have a global organization where you have many countries where you operate, there can be different cities within those countries which can control their own ranking profiles, but also partners which work with you. If you have a marketplace, for example, Adidas can belong to one of the cities, and then this group can control their own ranking profiles. Now, when we actually go and see the users, we can see that the admin user has access to, not assigned a group yet, but let's choose this organizational unit. Now we see that the admin is assigned to that group. We see that he's in Frankfurt, and then vendor is selected here. But now when we change that location, he's now moved to a different country, and the user will also be seen here at a different location. Each user can have their own roles assigned. We can have roles, as you see here, set up with the permissions. We can add, again, as many roles as we want, and then use different parent roles as the source of those permissions. Permissions are set for every action which can be performed in our system. Now that we described the basic configurations, functions, context parameters, assignment groups, and also a little bit of the security approach here in the platform, let's move on to the strategies. In strategies, the strategies are used to group functions together. For example, let's look at this destocking. Destocking has different functions like the stock weight, discount weight, then transport weight, and then a gross profit rate. Those are telling our strategy how those particular items will be ranked based on those parameters. We can dynamically set and change, and everything that will be using this strategy will be affected by the weights, which we are setting here as functions. Now those strategies can be assigned into the traffic in the form of assignments. For example, Here in development, we can create this destocking assignment, which will be applied only for a few days. So you can see here that we have a starting date, end date, match function if we have multiple parameters overlapping, and then we also have context parameters. Let's say this is the vendor Adidas and shoes. And then we can also set those weights, which will be applied to this kind of traffic. Now we can see that this one is applied to the development traffic. To do some experimentation, we can move development traffic. Now we'll put 1% of the traffic into the development group. At that point in time, when we are passing this traffic, we basically collect some metrics. We can see the business impact of those groups, group A, B, production, and so on. And we can see different metrics will be reported here: conversion rates, bounce rates, and other statistical parameters. We work with our customers to implement more as they need in everyday work. Now when we move from assignments to other things, for example, to test how our queries are performing with given configurations, we can take our query and now we see trousers, so we can select in which groups we are passing this query. We can select the date when this query is simulated, as well as select different parameters which we would like to set with our query. Then, of course, there is another aspect of our configurations. Each element can be pinned, bared, or boosted. So these are individual weights for every item if we like to change the behavior of a particular item, not the whole group of items. To wrap up, this demo shows how with Vespa you can dynamically control your ranking profiles without waiting for updates. Vespa gives you flexibility in real time in e-commerce platforms. So to wrap up, let's take a step back and look at the bigger picture. Now, one of the core challenges we talked about today is that relevance in modern e-commerce is much more complex than it used to be. It's no longer just about matching words in a product title or description, because a good ranking decision has to balance many different signals at once. Now, the problem is that many traditional architectures weren't designed to handle this level of complexity because signals end up across multiple systems, and those systems evaluate signals separately. So when that happens, it becomes much harder to combine signals effectively, experiment with ranking logic, or even run machine learning models that can actually capture relationships between those signals. And what we've shown today is a different approach. So instead of stitching multiple systems together, Vespa evaluates signals together inside a unified ranking pipeline. So that means keyword relevance, vector similarity, behavioral signals, business logic, and machine learning models can all be evaluated in the same place and in real time. Now, this architecture makes it much easier to build more intelligent ranking systems and really enable you to balance customer intent, product quality, and business goals at the same time. And ultimately, that obviously leads to better outcomes around product discovery, customer experiences, and business results. So, with that, we would love to open it up for questions and hear what challenges you're seeing when it comes to relevance and ranking in your own systems.